Hey there, everyone. My name is Ryan Schul. Welcome to my analytics channel here on YouTube. So in the project today, I want to take you through some basic plotting, charting, and basic analysis of different types of data, different data frames, and we are going to focus on analyzing New York City parking ticket data. I found this online. I found the data source right here. I put a link at the bottom of my Jupyter notebook, and I can share that with you. Now, I'll give you a heads up, okay? Just a preliminary warning here. This is government data. I've done a couple videos on government data. It's always like a little bit weird, a little bit wackadoodle. I don't know why they do this. Either they don't pay attention, or they don't care, or they just don't know what they're doing. I don't know what drives all this. But there's always like a catch or a gotcha. The data is a little bit messy. It's a little bit screwy. It's a little bit wacky. You don't really see this with companies that were designed around data. So like Google doesn't do these things. Microsoft doesn't do these things. Amazon doesn't do these things. But I've worked for companies that aren't data-centric companies, and they have issues, and you just have to deal with it. So just one thing, and I think most of the data is pretty solid. I wouldn't question most of it, but some things just don't add up whatsoever. So this says parking violations issued fiscal year 2024. You see where my mouse is? Like I'm not even making this stuff up, guys. This is legit. This is legit concern. Parking violation issued fiscal year 2024, and the URL that it comes from, parking violations issued 2021. Okay, I'll refresh this just so there's no ambiguity here, so there's no uncertainty. So it says 2021 right here, right? You can see where the mouse is. And right over here it says 2024, and I just refreshed the URL. So I'm not making this stuff up, all right? So I went through the data. I think it's pretty solid. I think it's pretty intact, but you're going to see issues and things that are just questionable, and it just makes you say, what? Like, what are you guys even doing? I don't know what this is. I now know who's in charge. I'm just reporting. I'm just doing the analytics. I'm just doing the analysis here. That's it. So analyzing New York State parking violations by borough, by month, by day of week, by time of day, things like this. We're going to look at this from a few different perspectives, and I'll take you through it. This is nothing super complicated. It's not like overwhelming, or, people will look at this and feel befuddled and confused. It's pretty straightforward, okay? But let's just pause for a minute and say, why would we even want to do this, right? It's like the reasons are many, actually, for city planning, for law enforcement, for traffic congestion and safety management. These are some concerns for New York City, right? How do we manage the congestion of traffic, right? They just implemented congestion pricing a few months ago, going through the tunnels and bridges. I think anything south of 59th Street, which conveniently includes Queensboro Bridge. So you pay the extra toll when you go over that, and everything downtown, the Lincoln Tunnel, the Holland Tunnel, they got you from all these angles, right? So it does cut down on traffic. It does cut down on congestion. However, there's fewer people coming into the downtown area, going to Chinatown, going out for dinner, going out for lunch, because it's so expensive now. It doesn't make it even worth it anymore. So I kind of feel bad for the businesses downtown, but whatever. There's always a trade-off, right? Less congestion, less traffic, less business opportunities, less growth and development for the downtown area. But that's the gotcha, right? So why else would we do this type of analysis? Equity, fairness, machine learning, predictive analytics, right? So we can build models to learn what is traffic congestion going to be like in the future at different times of day, different days of the week, different times of the year. Is there seasonality effects? Like, I didn't get into all that. That's a little bit more advanced. I have several videos that discuss that, so I'm not going to include that in this. I don't want to duplicate or replicate things. I don't believe in that. But just also revenue analysis. And this data set is coming from the site I just showed you. This is the name of the file. So I'm not going to run this right now because it does take a while to do the import. When I did this, I tested this yesterday and set up everything. It took like 5 minutes just to import the data. So I'm not going to redo that and go through the whole scenario all over again. It has, I think, about 5.5 million records. I took a sample to do my analysis, so I'm looking at 500,000 records, because 5 million is just going to crash my computer. So that's not going to work, right? And I'm a huge fan of just getting it done and just getting something out. And having some kind of deliverable. If I try to do the full data set, it's going to crash. I can't go to stakeholders and say, yeah, well, I've got nothing to show you. So I did nothing all day with my time, right? Like I'm going to take a small sample and get something done and be productive. So I picked 500,000, but this is not the entire data set. And if you want to do it, if your computer will handle it, that's great. My laptop is a T14, the ThinkPad T14, solid state drive. But a little bit older, and it just can't handle these massive data sets, right? So I'm not even going to try. And it is, because it's 5 million rows, it's also about 5 gigs of data. I'm going to delete the file as soon as I'm done with it. I'm not going to save this on my desktop. And the last thing I was going to say, what was I thinking of? I guess that was it. Okay, so that's a good intro. That's a good intro. So let's get into it. Let's see what we can do with this data once it's set up and loaded here. Okay, so we can go ahead and take a sample of the data. So I have df sample right here. That comes from reading this CSV file, right? Going back to my desktop, but only taking 500 records, right? So it is a random sample. So the data should be pretty much normally distributed. It goes across all of 2024, I think, even though the URL says 2021. So that's kind of debatable, but I think it's 2024. And you'll see all the months of the year, all the days of the week, all the times of the day. So because it's pretty much normally distributed and it captures everything, I think taking a sample of the data is pretty representative of the data. So if I hit Control Enter down here, we have df sample that comes from this above. And we just have violation by county, and we have value counts, and we reset the index. The index of the data frame is basically like the rows. They start at 0 and go up to whatever this is. In this case, it's 500,000. In the full data set, it's like 5.5 million. I think that's what it was. So we're getting like 9%, 10%, whatever the thing. It's like around 10%, a little bit less. So most of the things you'll see in data science is either counting or summing or averaging. An average is equivalent to a mean. And there's all kinds of different analytics. There's z-scores, there's standard deviations and variances and everything. But for the most part, like I would say 90 to 95% of the time, all we're doing is counting, summing, and averaging. So this is a value count. You saw this, I just refreshed it. So most of the violations happen in New York County. It's called New York City. This is Queens, Brooklyn, Bronx. This is K. So I'm not even sure what K is. I think this is Brooklyn, but they forgot the B. I think this is Queens, but they shouldn't be more standardized, QN. So that's what I'm saying. The data, I think is like okay at best, but this is the New York City government, guys. So, you get what you get, and that's all you can expect. Like, you can't expect things to be absolutely refined and absolutely perfect over here. Here's Kings County. This should be Brooklyn. This should be Staten Island. I don't even know what MN is. It sounds like Minnesota. I don't know what that even belongs in here. R is nothing. Bronx is Bronx. And that should belong over here. And Rich is like literally nothing. Okay, so take that with a grain of salt, right? So here we're doing the same thing, value count, getting the N largest. So this is number largest. And again, we're resetting index. So we take this data frame, take the 20 largest and reset the index, because if you don't, then you'll get like an index that's a little bit wacky. And then you could have a, what's it called? A double index data frame or something, multi-index data frame. And you don't really want that. It's just hard to work with. So if you just do reset index at the end, it just makes everything nice and neat and clean right there. Okay. So these are the top vehicles that got issued traffic violations, mostly tickets, maybe a speeding ticket, maybe a parking ticket. It could be driving in a bus lane. We'll see a little bit later, like what these violations break down to. This is the categories of vehicles that receive tickets. So it's kind of interesting that Toyota, Honda, and Ford get the most. I think just because these are the most common cars out there, right? You see Chevrolet, MEB, I'm not even sure what that is. I know some BMWs, Hyundai, Lexus, Infiniti, Volkswagen, but I think by and large, these are the most popular cars, Toyota, Honda, and Ford. So these are the most common manufactured cars that get tickets, right? So I like that. I'm going to change this chart just a bit. I like to make these pretty consistent. I like the width to be 1100 and the height to be 600 or 800, depending on what I'm doing. So let me just refresh this thing right here. and I'll share all this code with you guys later today. So top 20 vehicles by violation count. So you can see the same thing over and over again. Value counts, n largest is 20. We reset the index. We're getting the vehicle color before we got the vehicle make. So very similar type of thing. We can create a temporary data frame right here, make counts. Then we use that data frame right here. On the x-axis typically is the language or the words or whatever you're using, the alphabet, right? And the numbers are usually in the vertical column. So the X is horizontal, Y is vertical, although it could change. You could take that and transpose it and flip it. You can literally make it look like this, count. All right, you can change this up here and refresh it. And that works too. I think it's just a little bit nicer the other way. I think it's a little bit more intuitive. You want to make your plots and charts tell a story and make it easy for people to understand what's going on, and kind of try to what's the word? Not discourage, but try to eliminate confusion. Right? You want to create coherence and understanding. If you create a chart that is very ambiguous or actually deceiving or misleading or very confusing, that's not helping anybody, right? Somebody should be able to look at this chart right here and say, oh, I think I understand what's going on. This is by vehicle color, and this is the frequency of these vehicles that get tickets in New York City. So this is gray, this is white, this is black, this is blue, white, black. So again, these should probably be consolidated and have like a two-letter or maybe like three-letter standard. But you can see they have gray right here, and they have GREY over here. And if you spell it different, if one letter is off, or even if you have a space between it or a space at the front or at the end, the computer will interpret that as a totally different color, and it's going to go into a different bucket, and it's going to be plotted differently, right? So again, this is New York City data, and New York City is not a data institution. It's not Microsoft. It's not Amazon, right? Data was an afterthought for these guys. They kind of do it, and they kind of like do a half-ass effort. So I understand the mistakes. I understand that you try to do the best you can do with what you have, but it's just definitely coming up short, and that's pretty obvious right here. But anyways, like let's continue on. So here's distribution of parking tickets by month. So this is pretty interesting. We have the month order. I'm going to use that right here. If you look here, this is re-index by month order. So you saw the index over here. All right, we're doing reset index and getting the top 20. Okay, so that makes sense. And this is going to go in descending order by default. In this case, the computer doesn't know January, February, March, April. It doesn't know the order of the months, right? So we have to tell it the order of the months and force it to index. Otherwise, it's going to do just whatever it wants to do. Like, let me just run this by default. What do we get? Oh, I spelled the thing. Sorry. Okay. All right, it's totally my fault. Okay, so it's resetting automatically. So in some cases, if you want to see descending violations by month, July was the biggest and May was the smallest. Now, maybe this makes sense, right? If you want to say, okay, what's the biggest violation by month and what's the smallest, this could make sense. But I don't think most people want to see that kind of view. I think most people want to see a view that intuitively makes sense just through the course of time. Most things that are time-based, you want to see in time as time flows. You want to see like the highest to lowest, but you could, right? So it really depends on what the end game is here and what the goal is. So that's really up to you, but I think this makes the most sense. I think this is the most intuitive. Again, we get value counts, re-index by month order, and this is the months. And if you want to put December 1st, you could just put December over here. Oops. Put December over here, cut, paste over here, put a comma in between, and eliminate that comma. If that's your goal, I don't think so, okay? But I think this makes a lot of sense. So I'm just going to leave it as is. Let me save my changes here. File change, yeah, overwrite, yes. Overwrite. Okay, so we're doing good. We're halfway through this thing. Keep going here. So again, I'm setting the distribution by the day of the week. So the computer doesn't know Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. And you could have Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Saturday could be the end of the week. I'm just saying this is the order. I think this makes a lot of sense. you can do what you want to do. I'm just trying to set this up in a way that's intuitive and complements the way that the data should be reported, I think. So we have the down order over here that comes from here, and we do the re-index and then reset index so we don't get like a weird multi-level index. I've dealt with that before, and that's fine. You have to reset the index at some point, okay? Because it just creates like kind of like a pivot of the data. If you ever worked with Excel, it creates a pivot of the data, and you have to unpivot it. That's what that does, okay? So here's the day of the week and the counts of each. So you can see Tuesday is probably the biggest. What is this? If I put the mouse over 80.33, oh, this is a little bit bigger Thursday. And then it kind of dips down Saturday and Sunday. So there's fewer tickets issued on Sunday. Probably most people are in church and they're not driving their cars around all over the place. So they're not getting tickets, right? And actually, like in Sunday, in most neighborhoods, there's no ticketing. But apparently, some neighborhoods do enforce parking tickets, and we get 49,000 out of, what was the original data set? 500,000. So this is 50. So 10% of the tickets actually occur on Sundays. So that's interesting because in my neighborhood, there's very low ticketing, which sounds weird. And there's no alternate side parking either, which sounds weird too, but they never instituted that. And in New York City, I think in most neighborhoods, there's no ticketing, but apparently in some there is. Or somehow the ticket got reported on Sunday. I don't know if the ticket got issued on Sunday or reported. And again, this is New York City government data. So is it fully, is this bulletproof? I don't think so. We've already seen like the first thing I showed you. This is for fiscal year 2024, and the website literally says fiscal year 2021. When I refresh it, there's the evidence right there. So take it with a grain of salt. So here I'm going to look at violation time. So I'm trying to convert everything that comes in this field. Where was the time field? Let me look for it now. Time. Where's my time? Here's a date, right? So in some data sets, you see the date and the time together, and this one's kind of parsed out. Okay, so here it is, 6:25 a.m. So that's interesting too. Like, what kind of traffic cop is walking around at 6:25 a.m.? Because normally, I think ticketing, at least in my neighborhood, goes from I think around 8 to 6 p.m. or 7, something like that. Like, to get a ticket at 6:25 seems odd, but that's what you get here, right? Here's 7:27 p.m., 8:42 a.m., and 7:14 p.m. So it comes in a little bit messy. So we have to run this little script over here above just to get that cleaned up. If a.m., p.m., p. Otherwise, if not 12, then hour equals 12, and then we consider a.m., right? So we use a little logic to get things cleaned up. All right, and then we get the violation hour over here. So 641 over here, and this is 1923. And if we go back over here, so where's this column? Oh, it's kind of towards the beginning. So 6:25 a.m. and this is 7:14 p.m. So this is about 6:45 and this is 17 p.m. So that's how we get the validation or violation hour. Then we can plot that, Control Enter to refresh the chart. And we're almost done. Hang with me, guys. Hang with me for a couple more minutes. So this is the hour of the day when the tickets were written. So honestly, I don't know which traffic cop is running around at midnight issuing tickets, but apparently there's 3,500. It spikes up a little bit around 1 or 2. Most people are sleeping at this point, so it goes down to 4,000. But then you can see as the sun comes up, the number of tickets increase, right? And it increases during the day. And this totally makes sense, kind of decreases overnight. But this is kind of enlightening because I didn't know that traffic officers or cops or whatever they're called, people of the law, were issuing tickets at 11 p.m. and midnight and 1 a.m., 2, 3, 4 o'clock in the morning. I didn't know that, but according to this, they are. So maybe in some neighborhoods, in the neighborhoods that I know in New York City, I don't think they do this. I haven't heard that. In where I live, I can almost guarantee they're not doing this. But maybe in some neighborhoods, somewhere in the 5 boroughs, they are doing this. And apparently it's getting reported as these times. So it is what it is. I'm not going to argue with the data or fight it or go to war with it or battle it or anything. I didn't change anything here. All I'm doing is just showing you what is included in this data set. This is the last thing I'm going to show. This is called a sunburst chart. This comes from the Plotly world. So I love Plotly. Let me go over there for just a second. Plotly charts. So these guys have all kinds of real fun, interesting graphs and charts. Here's scatter plots, histograms, 2D histograms, bubble plots, bubble charts, contours. They have charts of geography, bubble maps over here. This is bubble maps across the world. This is like the world. This is an animated chart that changes over time. This is pretty cool too. You can zoom in and see the changes over time. I have a couple videos on these types of things and how these work. 3D charts, alignments charts, clustering, subplots, animated charts, and just all kinds of things. So I'm a big fan of this Plotly library. This is called the Sunburst chart, and I like this a lot because you can zoom in here and see where do most of the violations come from. So most of them primarily are photo school zone speeding violations. And if you click on here, you can interact with this. So you have bus lane violations, failure to stop at red light, MTA camera bus stop, 6,939 violations, mobile bus lane violations, so on and so forth, right? And then you click back here and you can expand it, and then you can see the subsets of data. So here's the red. This is failure to display meter records. Okay, so I think it's when you pay the meter and you put it in your windshield. This is no standing. This is no parking. It's hard to read this stuff. No parking, street cleaning. Oh, okay, street cleaning. Okay. So you can go back here and you can expand all of these subplots. So I like this a lot. It's pretty interesting. It's very interactive. No parking plate. I guess they had no plate on the car. Failure to display meter. No standing. And I just love the way how you can interact with the chart and expand it and contract it and then see all the details of that. So that is pretty cool. I'm going to delete that. I was experimenting with something, didn't really work out. So in conclusion here, New York City collects over $500 million in parking fines, which is a substantial contribution to the New York City budget, right? The income of the city. This is a huge cash flow. In all of the analysis I did, I couldn't find one single column that talked about what was the actual cost of the fine. If you look closely at the data, I can't see it here. I'm not going to refresh this thing because it takes 5 minutes to load the data. But if you download the data set and run these experiments, you'll see for yourself, there's no explanation of the amount of the fine. So is parking in front of a fire hydrant $115, $100, $125, $150? I don't know for sure. I think it's 115. I think that you can Google it. But what's a just a generic parking fine? Is it 60? Is it 80? If you park in front of a school zone, if you are driving in a bus lane, if you pass a bus when they have the stop signal out, I don't know what all these fines are. And it wasn't in the data set. I thought for a file that's 5 gigs, right? You have over 500 and 5.5 million records. There was a lot of records in the file. And they had no description of the cost of the ticket. What does this fine cost? What is the charge? What's the actual numeric representation of the violation? There's no evidence of that whatsoever. I thought that was weird. So of all the records, I couldn't figure that out. But I Google it. It's about $1.5 billion for New York City every year. So that's a lot of money. They got me a couple of times. I just paid and got that monkey off my back because I didn't want that following me all over the place. But it is a nuisance, and it definitely generates a lot of revenue for New York City, okay? So I just wanted to take you through that, the plots and charts, all the histograms, breaking down the data frames, doing the plotting, the data frame, counting and aggregation. So I think that stuff is pretty interesting. Hopefully this was, hopefully this was a good use of time. Hopefully I could drop some knowledge and help educate people. That's what these videos are for, to share what I've learned over the years. I've been doing this stuff for Python specifically for about 12 years, but data and analytics using other tools for about 22 years. And I've accumulated a lot of knowledge. I want to share that with y'all right here. So that's what the point of this video is, and all the others too, okay? So that's it. I'm going to wrap it up here, and I will see you guys in the next video. Talk to you soon. Bye.